So my name's Andy Felton. I'm the head of the product management team at Thermo Fisher. So I have the great pleasure to lead a very talented group of product managers who work with our R&D function and with you as the community of molecular pathologists to develop new NGS systems, products, and assays. So as Albrecht said, hopefully by the end of this talk, I'll have convinced you that we have some worthwhile products and that maybe you can decide what kind of product is relevant for you in terms of the size of the panel or the kind of molecular pathology testing you would like to develop. Over the last few years, as you've seen from Jose's talk, we've been developing a set of solutions that enable you to implement NGS testing in your pathology laboratory by doing that from end to end. So we cover, obviously, the design of the panels using a set of resources we have internally, including a database of all the relevant driver genes and mutations in cancer, from assay chemistries that enable you to work with very low amounts of input material, automated workflows that are streamlined, and then going down into standardized bioinformatics that are off the shelf and ready to use, and then helping you get those up and running in your laboratory through consultation with our clinical account scientists and service and support teams to help you get that up and running and go through those accreditation processes. So hopefully we have all the tools to help you build that into your lab. In terms of the kinds of panels that you would like to implement, one of our philosophies is it depends on what your current situation is in your laboratory. What is the reimbursement landscape in your country? Do they pay you a reasonable fee for a small panel, or they'll cover the cost of a large panel? So it depends on what your environment looks like as to the kind of panels that you need, and therefore what we've tried to do is give you options across a range of different tools. We've developed panels that cover both solid tumors as well as liquid biopsy, so you heard Jose's talk. We also, in the more translational space, in immuno-oncology for things like tumor mutational load or T-cell repertoire sequencing, as well as hemato-oncology for myeloid disorders. So we have a selection of panels. Some of them are listed on this slide. We have a more comprehensive view. If you go to our oncomine.com site, you can see all of them. From the solid tumor side, on the far left of this chart, we cover a range from about 160 genes through 50 genes to single or a couple of genes of BRCA. And I'm going to cover a few of our latest solid tumor panels, our latest Oncomine Comprehensive Assay Plus, as well as a selection of tumor-specific panels. And in the hemato-oncology world, we cover things like myeloid, comprehensive myeloid disorders, childhood cancer for pediatric research, and we have some new assays coming in B-cell repertoire sequencing, lymphoma, and minimal residual disease. In terms of liquid biopsy, we cover both lung, breast, and colon in terms of tissue-specific, as well as pan-cancer, about 50 genes in total if you want to have a wide variety of solid tumors. And in the immuno-oncology space, we cover from gene expression to profile the tumor microenvironment, T-cell repertoires, assays, as well as tumor mutational load. Just a quick word, we also have IVD cleared products in our portfolio, one of which is our Oncomine DX target test that's approved in both the US FDA and in Europe. We've had a long history of developing relationships with pharmaceutical partners for certain markers on those, as you can see from the list here. And we're very excited to announce this morning there was a press release on our relationship with Lilly Oncology and the LOXO-292 RET fusion marker. We'll be developing a companion diagnostic with them moving forward here. So moving to the case where you feel like you need a comprehensive solution for tumor profiling. This is our latest and greatest assay to be called the Oncomine Comprehensive Assay Plus. It covers over 500 genes, about 1.1 megabase of coding sequence for really comprehensive genomic profiling. SNPs, indels, copy number, including both copy number loss with some new bioinformatics we're going to implement, as well as copy number gain, and a very comprehensive selection of both fusions and splice variants. That 1.1 megabase of coding sequence will allow you to measure tumor mutational burden, and we have bioinformatics that will give you a quantitative readout of the number of mutations as well as mutational signatures, such as UV or smoking damage or homologous recombination deficiency pathways, if you wanted to look at HRD or DNA mismatch repair. It also includes microsatellite instability testing, and based on our AmpliSeq technology, you're able to start from as little as 20 nanograms of material and get a very high success rate, up to about 99% success. Covers both hotspots, focal CMV gain or loss, as I said, over 220 genes with full coding sequence coverage, and over 50 genes with a very large collection of gene fusion isoforms within them. It's very heavily optimized to give you the most efficient sequencing that we can get you. Obviously, a panel of this size requires a fairly high amount of coverage. On-target rates and uniformity we think are exceptionally good for this one and allow you to sequence efficiently. So, although we'll start with 10 to 20 nanograms, we're going to test the input level down to 1 nanogram of DNA RNA or a single FFP slice. Given the success rate we know from our previous assays, we think we'll have very low quantity not sufficient rates and automated to allow you to run on fine needle aspirates or even cytology samples. We'll have a full range of informatics, both for the tumor mutational load, the variant calling, and the microsatellite instability and the fusion detection. So that's the large side. If you're in a situation where you need a set of focused tumor panels, we have a new solution coming to be called Oncomine tumor-specific panels, really designed taking about 300 genes, designing 300 cancer driver and resistance genes, designing and testing those in the wet lab, and then inventorying them at the gene level such that we can provide any of those genes together in any combination to build a specific tumor panel. And what we'll give you is a set of 10 core tumor-specific panels, and then allow you to potentially add a few genes if you need to, along with the Oncomine bioinformatics solutions. So you'll have an end-to-end workflow automated on the Ion Chef and Gene Studio with the bioinformatics, allowing you for a small sample input. As long as you use the core panel of between typically about 10 to 30 genes, we'll give you all the variant calling pipeline optimization as well as the copy number variation baseline information. If you start to add a few genes, we'll then need to go into some specialized support packages to do those optimizations when you've customized the panel. But very simple to order off our AmpliSeq.com website. Here's the list that we'll cover with these 10 panels. So it varies from lymphoma and brachinus, so about 15 to 30 genes in the brachinus range, as well as B-cell lymphoma coverage. I'll show you a little more about that in a second, to things like gastric, kidney, or bladder, as well as prostate panels. So typically our Oncomine tumor-specific panels will run at about 10 samples per our 530 chip on the Gene Studio S5 platform. We'll have tested them on our Gene Studio 530 and 40 chips. They come with dual barcodes and ordered from our AmpliSeq.com, and as I said, customizable. Two specific panel details. The lymphoma panel will cover a wide range of lymphomas, B-cell lymphomas, follicular, mantle, and marginal zone. And the BRCA expanded will be about 15 genes, about 1,000 replicons for homologous repair pathways. We think it's going to be particularly useful with olaparib and the other drugs in the PARP inhibitor space. So the brachinus panel itself, 7 genes with hotspots, 15 genes with focal CMV gains or losses, and 15 genes with whole genome coverage. So that will cover, as you can see, genes on labels as well as guidelines, and 15 of those genes used in currently clinical trials. For lymphoma, you see the here, so about 7 hotspot genes, 24 genes with CMV, and 18 full codons sequence. All well optimized to run. This is showing you the uniformity, on-target rates and uniformity. So the on-target rates for FFPE are shown in the light blue here, and the on-target rates for genomic DNA, in this case measured with N12878, are shown in the darker blue. So there are four ones, and the black is the uniformity, and then the uniformity for the germline is shown here as well. So very high uniformity, on-target rates around 70% or higher. So in the hemato-oncology space, as I said, we have currently our Oncomine myeloid assay, our Oncomine childhood and young adult assay, as well as some new assays coming, including our myeloid minimal residual disease for detecting rare mutations, so follow-up cases, as well as Oncomine B-cell repertoire assays to complement our Oncomine T-cell repertoire assays. So a little bit on the B-cell repertoire assays. They are designed to really help you identify malignant clones and determine the unique CDR3 sequences. They also can measure the amount of somatic hypermutation and also track those clones for longitudinal testing for minimal residual disease research. And there's a full set of informatics already implemented for both the T-cell repertoire, and we'll have that for the B-cell repertoire as well in our Iron Reporter solution. So for B-cell, for our lymphoma assays, I covered, right now it will be B-cell lymphomas, and we'll then progress to T-cell lymphomas next year, and again, the same set of full bioinformatic solutions, starting from as little as 10 nanograms of input. Here's the schematic on our B-cell repertoire long read assay. So you can see we are priming out of the constant region using our 400 base pair sequencing capability. It's about a 410 base read, goes through the CDR1, 2, and 3, the VDJ region. So it covers those as well as the CH1 domain of the isotype, enabling somatic hypermutation calling, determination of clonal expansion, and looking at tracking clonal lineages by descent. We also have constant region primers in there, help us designed against all B-cell isotypes, so you can look for isotype switching. And in this case, this assay runs on RNA, and it's from 25 nanograms up to about 2 micrograms of RNA from whole blood, bone marrow, PBLs, or PBMCs, or fresh frozen material, so designed to work with RNA. The corresponding short read assay covers the CDR3 region only, and this assay will work from either RNA or from genomic DNA from FFPE tissue as well. So if you want to track rare clones to low LODs, particularly down to things like 10 to the minus 6, so very rare clones, and track those, this would be the assay you would use. Again, 25 nanograms of DNA or RNA up to about 2 micrograms of input, in this case from standard samples as well as FFPE. Lastly, the Oncomine myeloid measurable residual disease. This is a mutation-based assay to detecting mutations at ultra-high sensitivity using our AmpliSeq HD-based chemistry that contains the molecular tagging as well as dual barcodes to enable you to detect variants from between 0.1 and 0.01% LOD. So it will be the first assay that we developed for routine use for MRD and compatible with home blood or bone marrow. Again, a complete workflow with bioinformatics tools built in, and both genes and fusion transcript targets for comprehensive coverage. So hopefully that's given you a sense of what we have and whether you should use a more comprehensive solution or a focused solution. But hopefully what you'll gain from this is that we can help you implement those in a pathology laboratory if you haven't done so yet, with the end-to-end workflow and the support tools, and happy to answer any questions. Thank you.